Hello friends, welcome to our channel. Now we are going to continue the part 5 of chemical reactions and equations. Now in this one we are going to discuss about displacement reactions. Displacement, change of place. For example, just we'll imagine one thing. Two people are dancing. Compared to the second one, the third one, the one who is doing nicely. For those, we are replacing the second one and the third one is coming and sitting here. Okay. So, that pair is coming. Like those, the same way in metals also, we are saying that slow reactive metals can displaces by fast reactive metals. That is what we are calling as a displacement reactions. Okay. So, in this displacement reactions, when you are coming here single displacement reactions. These reactions we are calling as a single displacement reactions, or we can also say it as a substitution reactions. Substitution reactions. And here I wrote reactivity series are there, you see. Potassium, sodium, barium, strontium, lithium, calcium, magnesium, aluminium and manganese. These all are the fast reactive metals. Okay. So almost 1A group and 2A group elements are belongs to metals in the periodic table, and D block elements also we have some metals like manganese. Okay, manganese will be in the D block element, and when it is coming to the moderate from zinc to hydrogen, you can ask, ma'am, hydrogen is not a metal, then how we can? Hydrogen actually because of one electron, it acts like that electron can loses or gains electrons. So depends on the situation, hydrogen can act like a metal or a non-metal, positive ion or negative ion. Okay, so hydrogen also will comes in the reactivity series, we can say. And when you are seeing the here copper, mercury, silver and gold, platinum, these are called as a noble metals. These are very least reactive metals. These are very least reactive metals. Okay, so easily these metals can displace us by the fast reactive metals or the moderate reactive metals. Okay, so this reactivity series compulsory we should remember in case of this displacement reactions. So in this one here you see zinc. Zinc is reacting with the copper sulfate. Zinc is actually the original color is a grey, non-malleable metal is a zinc, and that is not belongs to transition element, and it is in the grey in color. And when copper sulfate, when you are taking in the form of aquatic solution means the solution will be blue in color, copper sulfate. Okay, so reaction is happening here, same thing. Here A plus BC gives AC plus B will come out. So here the zinc is displacing compared to the series. Here you see zinc is here, copper is here. So zinc is displacing the copper and forming as a zinc sulfate. The color of the blue solution will disappear. This reaction it will take nearly 45 to half an hour, 45 minutes, more than 45 minutes or to 1.5 hours it will take. So zinc sulfate is becoming a colorless now, and copper as in the form of brown color it will come. And when you are taking the iron, the second same one only, iron is reacting with the copper sulfate. Even you see here, zinc is here in the moderate reactive series and iron is here. So compared to this, even iron also fast reactive only. So that is the reason iron is displacing the copper sulfate and giving as a iron sulfate and the copper. Okay, so here also iron is a solid one and copper sulfate aquatic solution we can say, always they again blue in color, and here the color, here it is forming the blue color turns to green color. Blue color turns to green color. This color definitely we should remember. And copper in the form of reddish brown color, same as usual like how we got here. The deposition will occur here. And here sodium you see, sodium reacting with water. Usually sodium we know very fast reactive metal. When you are adding in water, sodium immediately, like sodium wherever we chance we are giving, it will start to react. Right now sodium. So to avoid the vigorous reaction we are storing under kerosene sodium. Okay. So when you are adding a water, sodium is a fast reactive and compared to the hydrogen. Hydrogen in the middle reactivity series. Okay. So then water is going to dissociate into H plus and OH minus ions here. So this hydrogen is reacting here forming as a water OH minus ion, that is in the form of sodium hydroxide aquatic solution, and hydrogen gas will be liberated here. Okay. So this is also here the hydrogen ion is displacing with sodium, then it is forming as a sodium hydroxide. And here you see the next equation, AgNO3, silver nitrate. Silver nitrate reacting with the copper. Silver nitrate usually colorless in the sense white color, normal colorless only we can say. So aquatic solutions we are taking here. And copper, reddish brown in color will be there. Copper like copper funnels, copper tunnels we are taking. So this copper is displacing because compared to the Ag is a noble metal. There is no reactivity. Even it won't, only oxidation can happen, but other reactions it won't happen. Okay. So copper here, copper is displacing the Ag here. Okay. So copper nitrate is forming, and then silver molecules are coming in the form of grey color, and the copper nitrate, color of the copper nitrate solution is blue in color. Okay. We can say this one also. Next you see another reaction. Iron oxide is there. Iron oxide, Fe2O3. Ferric oxide. Ferric. Iron have 2 and 3 variable valencies. Okay. So here iron valency will be 3. Oxygen valency will be 2. So ferric. Ferrous. Ferric. Lower valency will be OUS. Higher valency will be IC. Ferric oxide. So ferric oxide is reacting with aluminium, forming it as aluminium oxide, and then it is giving as iron in the form of molten state. In the form of molten state. The same thing here also, iron molecules, iron atom. Okay, iron atoms are reacting with the water molecule, forming as a Fe3O4. This is actually amphoteric oxide. This is amphoteric oxide. This oxide will be their magnetic behavior. Okay, magnetic behavior will be there for this. Magnetic oxide also we can say for this. Okay, and here hydrogen will be displaces out, hydrogen gas. And when you are taking here magnesium, magnesium you see in the reactivity series, here is there after calcium. Magnesium belongs to 2A group element. Okay, and so here 2A group element, and it is reacting with the zinc oxide. So zinc is here in the series. So it can displaces easily, forming a magnesium oxide and zinc. And here all the displacement are happening substitution. This is taking that and coming and sitting here in the place. Okay, this is about the metallic. Almost all the displacement reactions are redox reactions. I will explain you how it will be. And when in case of non-metals, 7th A group elements like fluorine, chlorine, bromine and iodine, these are the also reactivity series we can say, because highly reactive are the metals in the periodic table because they are located in the left hand side of the periodic table, and the 7th A group elements also reactivity series is more because the chemical reactivity will be increases from left to right we can say. Okay, so when it is coming to the non-metallic, 7th A group elements will be in the form of top to bottom. So chlorine you take here, chlorine. So compared to chlorine, potassium bromide it is reacting. It is forming it as a, see, this chlorine will come here and the bromine is coming out in the form of diatomic one. Okay, and the liquid non-metal, the only liquid non-metal is a bromine. And here you are taking bromine gas reacting with the sodium iodide, forming as a compound sodium bromide and iodine. The only non-metallic element shows the lustrous in nature, that is iodine. Okay, so like this we will say. And all displacement reactions are, we can give the examples are redox reactions. Redox. Redox means reduction and oxidation. Both processes are happening in a same reaction. So we can say that if the oxidation and reduction both are happening in the same reaction, we can say they are redox reactions. For example, you take here oxidation number of zinc here you take. Always metals are monoatomic. So monoatomic or elementary form, always the oxidation number will be 0. Okay, and copper here +2, here -2. Okay, so here when it is coming to the zinc +2, -2 will be there, copper 0. Okay, so now zinc oxidation number is increasing to +2. Zinc oxidation number is increasing to +2 and copper oxidation number is decreasing to 0. Okay, so increasing oxidation number we are calling as oxidation. Increasing oxidation number we are calling as oxidation, and decreasing oxidation number we are calling as reduction. Okay, so almost wherever you are taking, even you take in this equation, like here +1 is there, here minus, okay, here 0. So copper, when it is coming to here +2 it is coming, and here Az 0 it is coming. So when you are taking Az +1 to 0, decreasing oxidation number, and copper here +2 is increasing, 0 to +2. Okay, so this is oxidation, this is a reduction, decreasing oxidation number, and this is increase in oxidation number, so we can say it as a oxidation. So like this we can say all the displacement reactions are redox reactions. All the displacement reactions we can say it as a redox reactions. Now the next reaction we are going to see, that is double decomposition. In the previous one we discussed about displacement or substitution reactions. Here also substitution will happen, but the substitution how it is happening? Exchange of ions will happen. So here the common one, AB is a compound, okay, AB is a compound reacting with CD, and it is forming the exchange, like here plus and minus, here plus and minus, this plus will come with this and this plus will come with this. Okay, so that's why AD and BC compound is coming. For example, here I gave C, silver nitrate. Silver is a metal, so metals are electropositive, so positive. Nitrate ion, NO3 minus, and then Na plus and Cl minus. Okay, so now this Ag is going to react with the Cl and Na is going to react with NO3. Okay, so that is a nitrate ion. So then it is forming as a silver chloride. Silver chloride. This is called down arrow here we are mentioning. Okay, so indication of this down arrow we can call it as a precipitate. Precipitate. Shortcut I mentioned here as a PPT. Okay, so precipitate means insoluble. Any liquid substance when the two reactants, two liquid substances are reacting here. That's why I mentioned here aquatic substances. All the precipitation reactions they can observe only in the aquatic solutions. Okay, and the insoluble solid is forming. That insoluble solid only we are calling as a precipitate. Okay, so another example we'll see. And these precipitation reactions are of two types: neutralization reaction and the precipitation reaction. Neutralization reactions you take when acid and base reacting each other forming salt and water, we are calling as a neutralization. Okay, for example you see here hydrochloric acid reacting with the sodium hydroxide forming as a compound sodium chloride and water. Okay, not only this, even the many acid base reactions we can take it as a neutralization. Like many examples, whenever your stomach is more of HCl, you are using some supplements like basic substances like you are drinking. Okay, so that we can give the neutralization to reduce the acidic nature of that one. And whenever the soil is becoming a more acidic, then you will add some basic substances to neutralize that one. And factory, next ant bites are there. Ant bites, what will happen? Ant will secrete the formic acid. That formic acid, when you are rubbing with the calamine solution that contains a zinc carbonate, okay, so that is going to neutralize with the basic substances. Like this, in our daily life we can give many examples for the neutralization reactions. Okay, and the second one of this one, here I will give you another example. See here, H2SO4. Okay, H2SO4 is reacting with magnesium hydroxide, MgOH twice, forming as a compound MgSO4 plus water molecule. Okay, so then we can say here this one balancing we need to do. 2 hydrogens are here and here 2 hydrogens are there. 4 hydrogens should be total, and here 4 oxygens and 2 oxygens, total 6 oxygens. 4 plus 1 only here, so when we are writing a 2, then this is balanced. Okay, now hydrogens are balanced, oxygens are also balanced. Okay, and the next one, precipitation. The same here what we discussed. Barium chloride, aquatic solution of barium chloride. We are adding to that sodium sulfate solution, forming these reactants. Both are exchanging their ions, and forming as a barium sulfate. Okay, this is the insoluble white color PPT. Insoluble white color solid one. That is why I mentioned here as a solid. Okay, and sodium chloride. And you take another example. Copper sulfate is reacting with the hydrogen sulfide. Copper sulfate with the hydrogen sulfide, And here this copper sulfate is reacting plus and minus. This will come with this and this will come this. Okay. So copper sulfide and H2SO4, sulfuric acid is coming. Cupric sulfide. This will give the black color precipitate, we can say. And aluminum chloride is reacting with ammonium hydroxide, forming as aluminum hydroxide and ammonium chloride. Even this we can say aluminum hydroxide is an insoluble one. And lead nitrate, potassium iodide. Here this reaction we discussed in the changes of chemical reactions, like characteristic properties of chemical reactions. There in the case of color change reactions. Okay. So here lead iodide is giving the yellow color. Okay. This color definitely they may ask in the board exams. Okay. Next, what is the difference between a precipitate and residue here? Precipitate, usually the precipitate, when the chemical reaction is happening, that chemical reaction, it is going to the remaining after the chemical reaction is some solid amount will be reduces. That we are calling as a precipitate. And residue, whatever the remains after the physical processes like evaporation or filtration, the some amount of thing, when you are doing filtration, like you are taking the funnel, keeping a filter paper and something insoluble solid components are settles in the filter paper. That we are calling as a residue. Okay. And all these displacement reactions are may or may not be redox reactions, because when you are observing here, you take here just hydrogen plus 1 only oxidation number here, chlorine minus 1, and here also plus 1, here also minus. So there is no change of oxidation numbers when you are coming here also. Here plus 1, here minus 1, and here also plus 1, and here minus 2. There is no change of oxidation numbers here. Okay. So that is the reason we need not of saying this one. Okay. And here in this reaction alone, you observe here in this reaction, stannous chloride. Okay. So here tin valency is a 2 initially, plus 2. Okay. And it is coming to this, here plus 4 it is forming. Okay. Plus 2 to plus 4 it is changing. And next when you take here iron, iron will be here 3 plus 3 valency will be there, and here plus 2. Okay. These two are having a variable valencies. Okay. So plus 2 to here plus 3 is there, plus 3 to plus 2. Only in this reaction redox is happening, means reduction and oxidation both are happening, and other reactions we may not observe. So that is the reason we can give one conclusion that all the double displacement reactions may or may not be redox reactions. Okay. I hope everyone